Yeah.
Yeah, it is.
Okay, can I start?
Yep. Thanks for waiting.
Yeah, cool. So, topic of my today talk is code instrumentation for performance optimization. Quickly about me, my name is Gleb Morgachev. Right now, I'm core development team and integration team lead at Product Science. We are doing performance optimization, automatic instrumentation of mobile applications for Android and iOS. Before I worked like data scientist at JetBrains in the project of making code search engine based off ML, code analysis with ML, and some code generation by natural language. Before that, I worked at Research Institute, ISPRAS. We made static analysis. We experimented with ML and NLP for code analysis also. Yeah. What I wanted to talk about today, quick introduction, what is product science? I wanted to high level show how people usually working on performance problems in general. Then I wanted to focus on some instrumentation part of performance analysis is profiling, tracing. I will tell you how it works, when it should be used, when it should not be used, which problem these approaches have. Then I will describe how to use tracing for performance optimization on examples of Android app mostly. And then I will show how we at Product Science suggestion to simplify this process, and I will highlight problems of this process, and then our approach how to simplify that in our tool and concept which we are suggesting. Yeah, okay. Let's start. Working on performance mostly consists of two different parts. First of them is monitoring system. It's in most cases made on real user monitoring. Such tools are collecting metrics, some target metrics of app, some user interaction with some when user click, when user scroll, and something like that. It provides developers with some high-level picture of how application works, which part is slow, which part is fast, which part is popular when we are doing requests to backend. But it doesn't provide developers with any code level details actually. So it's about some predefined metrics, predefined backend calls, user interaction, and so on. And the second part is apps instrumentation. It's already analysis of program dynamic behavior when we are analyzing the executed code itself, executed method, and executed line of code. And it has two different approach of how to do that, how to work with that. Not only these two, but they are most popular. The first is profiling, and the second is tracing. Let's view in details on profiling. So what is profiling? Is approach when we automatically generate some statistical summary of program execution, collection data of memory usage, of CPU utilization, frequency of method calls, duration of some method calls, And then we are showing, not we are, but such tools showing developers some report of this method was called this number of times. It takes this time, and the memory usage at this time was that, something like that. How it works usually? Most popular way how to do profiler is sampling. It likes program is executed on some real user flow, real client pipeline. Then program is automatically interrupted during this execution. And when program is interrupted, profiler visits all threads, all call stack, and collect data about functions which are executed right now. So really, such profile collect all call stacks and all methods, and collect current memory usage, current CPU usage, and then profiler repeat such procedure during whole execution of program, for example, every 10 milliseconds. So it doesn't collect, I have visualization, for example, program is stopped here, is stopped here, is stopped here. We every time grab all call stack and getting statistics. After that, we will have number of sampling, number of iterations when we get server handle request, exactly this call of server handle request, how much time on stack, how much time we have customer call on stack, order call on stack, and all that. And then such data is processed and visualized in form of flame graph. It's actually showing you how much time was spent on each method and how often each method is executed. It doesn't have any time axis, so it just calls how it longer executed. So we have this slice, this event. It means that execution of execute command takes longer, one of the most longer executed functions during this profiling session. When it's cool to use such tool, it's really quick approach to detect slow, frequent method calls. In some profilers, it even allows you to measure this data for line of code calls. So you can see that this line of code taking 9% of your execution, and it means that with such tool you can determine bottlenecks method in single thread application easily, and such methods should be optimized first. So you should make algorithm better in such call, or try to don't execute something like that. Also, it's really easy to detect high CPU usage, memory leaks, because you just have this data measured. But what is problems here? That output is extremely overwhelmed. You actually have all methods which such profilers see on stack. Each calls and statistics is collected for everything. Also, such tool cannot visualize at all multi-threading dependencies. So data can be collected for all threads, but then it's just statistics of execution without any time axis. You cannot compare and understand that oh, in this thread, we are executing that. In another thread during this time, we are executing another method. And last problem is sampling can lead to missing some methods because we are making sample, for example, every 10 milliseconds. It means if something is executed only one and execution time was less than 10 milliseconds, we will just don't see it. But it's still very useful tool, and it's very robust. It's really easy to use, and it's used by a lot of compiler to set up some right parameters for optimization and all such thing. In case of Android, Android has it. Let me wait. Has it inside actually Android Studio. So you can just click on Profiler, and here you can run some applications. It's our small app. Let me see the screen. Yeah, when it's loading. So you can easily record. Okay, 1 second. Sorry. Yeah, just remove session. So with profiling, you can easily record such sampled profile. Just choose call stack sample and click on record. And then on your device, you are doing something. Why doesn't it work? Okay, right now I'm clicking button in my simple app. I will show you the application on next step. And then you just see this program. And here you see flame chart of profiling. So actually you see that all calls was from example simple app. It was executed all the time. Then it's some Android calls. And here we already can see some higher level just Android system calls of message key, scaling some method, and such things. But once again, it doesn't have any time level visualization, and it's hard to understand, for example, what happens in program when this on-click method is called. But it's good statistical data of what is going on in program. Let me second to set up screen sharing on device, please. Oh, cool. So it was the application which I used when we just click button and it has delay until second screen is really loaded. Yeah, okay. Any question about profiling? Okay, then let's go to, so we have profiling, which is powerful but quite simple tool with only summary of what is going on in your application. But there are another approach how to record what is going on in app is tracing. So tracing is a process of recording small log events for execution of some programs parts. Pair of events with time step are recorded for begin of execution something and end of execution something. It may require adding this instrumentation by some approach into the app, but in most cases, this instrumentation looks just like we have some method. When it is entered, we add some event that it started. On the end, we have event that it finished. It just approach how to make manual instrumentation in Android actually, but in iOS or any other languages, platforms, and so on, it will look very similar. Yeah, how it visualized? Here we already have real time axis, and here we have slices. It's the time between some execution is started and some execution is finished, and we have such slice for each instrumented method. For example, it's a small Android app, and we added traced method in this method call inside, and it provides us with such slice traced method. I will show you this in application on next step. So slice is, as I said, slice is pair of begin end events for some traced code fragment, and each slice is associated with these timestamps and also associated with thread. So when we are working with this, time axis is available, and we can see really when some method was executed and what is executed in program in the same moment in another threads, and we have all this information. Also, all these events are visualized in real original order with real original timestamp, so we have real state application. And it allows us to really show, to not show, but to investigate, to look at multi-threading dependencies. So for example, when Android record slice for choreographer, it's when new frame is drawn. It in render thread and another thread collect bunch of slices for methods which are really making drawing of this choreographer. So with some additional thoughts, we can understand how they are really connected. And also, detailed trace contains all needed data for profiling, because really, if you will process trace, you can calculate the same statistic about the frequency of methods, about the average length of method execution, and also such tools often record memory usage, CPU usage, all the same. And the most cool thing that Android has implemented this framework for tracing, which I shown earlier, when you can create simply your custom slice, your custom instrumentation. And also Android platform itself is good enough covered by traces. So it provides you some visibility for when some draw frames is presented, when some choreographer is updated, when some work for animation by system is produced. So all this already visualized, and you can see it in just for any debug or production build already right now. So when to use it? It's already powerful thing to visualize a multi-threading program, and then you can manually investigate multi-threading performance issues. What is problems of that? Because such approach in most cases requires from you some careful manual instrumentation of code, adding these events, log something cool to which will provide you with some hints. Oh, here this is executed, there this is executed. And if we will instrument everything in code base, it will lead to a big overhead and will cause to not realistic picture. Because when you're doing profile with sampling, you can just easily increase time between interruption of app, and you are not really adding new executed code, you're just getting state of call stack. So its overhead is significantly less. And also, such approach still require quite hard manual investigation of multi-threading dependency. So you should look not only on the some method executed, but also on everything which were executed in another thread before this and at the same time. And let's take a look how it works in Android Studio Profiler. So in Android Studio Profiler, you can, oh, I should create a session again, not a problem. Yeah, you have some another tools approach. You can select Java Kotlin method trace. It's approach when Android Profiler automatically instrument for you all code into your application, and you can just click on record and start doing something in your app. For example, click on buttons and then stop it. Android Profiler is parsing, and here we already see real trace. So here just some system method executed. Here we are making some click, and we have perform click event, which handle our click. And also we have another click. And after that, it's a lot of calls which are really making update of your view in application. It's main thread. It also has another thread. Let's take a look on default dispatch async. So I think here I should show you application. On view created of first view, it just has some on-click listener. When we click on button, we are scheduling task in another thread, which waits for 1 second and then pass it back to main thread. So we have 1 second delay in application because of that. And let's get back. We definitely can see here in not main thread that sleep method is executed here with a lot of squirrel is on my window. With a lot of methods which is scheduling that. But what is the problem? It's really hard to understand, to match it somehow in this main thread, because a lot of things, a lot of overwhelming, and it's even for simplest, really small application. When I tried to record this example for some real size application, I tried to do this for quite popular message on Telegram. It just, Android Studio just failed because trace even for 5 second session was too big. So it's just impossible to take a look. And yeah, but let's get back to slides and summarize what we see in Android Studio Profiler. It has mode of full tracing when we have all methods of program execution visualized. App is extremely slowed down for big application, and trace is extremely overwhelmed. So it's hard to really work with it. And poor UI of such approach making investigation, multi-threading problems, matching of what is going on in different threads, quite hard. Yeah, but as I said earlier, Android has framework for adding manual traces and added in system. And it's the same example which we have. And this tracing is initially was proposed with not Android Studio Profiler, but with Perfetto Tool. What is Perfetto Tool is another more powerful instrument for visualizing traces. Actually, it's doing approximately the same, but when you are looking on traces in this tool, it doesn't have all method instrumented. You can pass any trace in such application, but by default, you put into such tool traces which are recorded just with standard default Android utils. Let's take a look how it looks like. So in Android, you can just click on button, record trace, go back and do something in your app, and then stop recording. And then trace is saved on your device. You can just with ADB, make command ADB pull this trace and upload to Perfetto. And then you can see trace which has all your custom slices like this trace method, which I added manually. And also it contains all these system Android default slices. Also, it has a lot of information about CPU occupation, memory usage, and all this. But let's focus on slices. What is cool that here we already can quite easily navigate. It's quite easily to work with different threads because you can pin them, you can compare them, you can make some flags, some annotation, and so on. So it's better version of Android Profiler. Let's get back. And actually, Android Profiler can do almost the same. In Android Profiler, you can also record system tracing, and you can see all the same. But once again, poor UI working with that significantly more complicated. And let's go that. Okay, we talked about a couple of tools which can be probably used for performance optimization, for finding your problem and fixing it. But how to really use it, how really looks like this pipeline of fixing something. In most cases, you first get some signal from observability tool, some metric, some regression test is failed, or some metric became worse, or user has some really frozen up when doing something. And then you should localize this problem in code. Maybe not exactly, but at least, oh, we are looking on that part of code. And we wanted to visualize that part of code. We wanted to work with that part of code. And then you should manually add trace events into a method which involved in this process. You don't need to visualize all methods, just some important step. For example, oh, here our application is doing this logic. Here we are doing that logic. Here we are creating this. So obviously this process is quite iterative when you're really step by step adding one interesting thing on trace, record traces, adding another interesting things, trying to understand how they're connected between them. Yeah. And also in the application, you should analyze different threads to detect segments of call which really slowing down your application. So you should make all this additional instrumentation, look on trace, and understand how methods executed in different threads are really related, are really connected. Because when you're looking at code in that cases, you have a, not hypothesis, but you have in your mind some view. I suppose that it will be executed in such ways that this method will be executed when I schedule it into another thread, but it can be postponed, it can be blocked by something else, and you will work with, you will look at threads to understand all such logic, all such real logic of your application. And yeah, let's try to make such annotation for our small app. And then you'll take a look how it looks like in app. So we have this onViewCreated method, which is really doing anything, contains all logic. And let's just say, for example, I wanted to visualize all what is going on here. I'm doing trace begin section for onViewCreated. All traces should be closed. Here we have this lambda, which is executed on click. We should add some tracing for it also. Let's name it somewhere like that. And we are doing the same for every another lambdas here. I will copy these names to have nested logic. Yeah, okay. For example, we started with this part, we recorded, we add this instrumentation, then we recorded trace. Let's take a look how it will look like. Boom, boom, boom. Yeah, so we will use Perfetto and just find this onViewCreated methods. Yeah, cool. So we have main thread, we have, we find the final executed method when we already switch back to main context. So it's that. Okay, let's put some flag here. I already did that, and pin this thread to just easily navigate it to this method later. Then let's find what is also how our logic is also looking in trace. We have this method launch, which really making this call to main thread. Okay, so we see that we are really waiting right here. And also we see that, yeah, in main thread, I have the place when it's really scheduled in set on click listener right here. So, and that's all logic of why we delayed. Actually, we understanding that to execute this one and switch to new view, we actually was waiting for we're waiting for this method executed in another thread. So, and here we're already understanding that to make it faster, we should optimize really this method and remove delay from this method. Okay. Let me continue. So it's how usually this process work. You are adding events, you are looking at them, you're reproducing logic. When you have all pipeline, all workflow, how your application work, then you're already detection which part of this process you should refine. Maybe you should not schedule something in new thread. Maybe you should prioritize execution of something or any other approach. But what is again problems of that approach? First, manual program tracing is required. It's iterative procedure of adding new events, of finding new places to cover, of looking on traces, on detection what is not covered yet. It's really hard. Also, tracing is working on method level, but in most cases, you want to optimize not some method execution, but some sequence. You want to optimize some time between your user make something and your user get really reaction from the app. So you should think not on method level, but higher level. And you should think about all logic of your application during this time, not only in one thread, not only in one method, all this. And to follow this logic from multiple threads may be quite hard, because when user click on some button, your application may do a lot of another things at the same time in another threads, getting some data, saving something in database. And if you do this manually, you will really detect, oh, I suppose this method is not related. Oh, I suppose this method execution is related to my workflow, my user flow. So it makes research quite hard and probabilistic, I would say. And let's present how we suggesting to resolve this issue, how we suggesting to work with it. First of all, we are using a new term, user flow, to work with it like with minimal item of optimizing. So what is user flow? It's one step process which starts when user making some action, for example, starting up or clicking button or scrolling, and finish with reaction. It's response of the application to this action. For example, when first page of your application is loaded for App Store, or when we switch to new view, or some chat is loaded in your messenger. So yeah. On code level, user flow is corresponding to a sequence of method calls which is triggered by an action and leads to a reaction. So it's sequence of different calls. And for example, in our case, we have action, click on button next, and we have reaction when second fragment is shown. So second problem is tracing of application. How we are doing this, we actually also automatically instrument all apps method. But as we just saw in Android profiler, it leads to huge overwhelming and almost useless trace. To resolve this, we make iterative procedure of filtering, and we are just removing from trace all not informative methods and making final tracing only for informative methods. For example, when you have some comparison in sort function call, it's really just some noise. We are removing such noise from traces. And what the results of this procedure? Manual tracing is not needed because initially we traced everything, and trace is not overwhelmed because after that we automatically removed everything useless. And app's performance becomes close to original, really close, and it's easier to use because you can focus on some real methods which are really important here. And also, we are starting work with new concept of execution path in some application. What is execution path in case of multi-threading app? Is sequence of methods calls which is triggered by an action and execute app's reaction. And this execution path can go through several processes for any number of processes. Also can go through only one process. But also each method in this path calls next method or schedule execution of next method in another thread synchronously or asynchronously. And also each next method execution is blocked by the execution of previous method in this chain. So in our case, example is really simple. We have this exactly same trace, but instrumented by us. Here we click on next. Here we have call of on-click listener, and it calls execution of on-view created launch with coroutines, and then in go back to main thread, lead to some fragment update, and then in that choreographer, we have new view. So we are, once again, what is that? I already said. What we are doing, we are automatically recording this plugin. We are automatically recording, scheduling something in another threads. We are automatically building this information. It provides us with easy to work with multi-threading apps dependencies because this information already presented on trace. And manual trace investigation is not required because you have something to start with. You can just click on something in main thread and find how it was actually scheduled, what the triggers of execution of that. And yeah, let me show how it works. So with the same trace, we have reaction here when the view is updated. We can see on video that here we jump from first fragment to second fragment. And here we have all sequence of executed method for here. So to update choreographer, fragment manager run was called automatically. This was called by with context method, which I shown you here. And this was scheduled from another thread. And we go back to place when the button is clicked. Yeah. Just for fun, wanted to show you how it looks on real application for Messenger, which I mentioned earlier. Let's click something random. Execution path can be something really detailed and really quite long thing. A lot of threads may be involved, especially when coroutines are used, for example, like that. So to execute this, it's actually started right here, and we actually executed all these seconds of methods. So yeah, it's execution path. It's how we are suggesting to use it. Yeah, actually, I think that's it. That's all I wanted to say. Any question?
So you basically are on Android, are you just adding Gradle plugins? And then that's what the is that what I think you said? You referenced something, I don't remember exactly what it was. Is that how you pull it into your project? You basically pull in like kind of Gradle plugins that detect your code. Is it
Yeah, actually,
like they insert code like maybe at compile time or something like that?
yeah, actually, to integrate it with project, we use just some Gradle plugin, which make this instrumentation automatically, and you're getting built with instrumented methods. Yeah. And then you're recording traces just with usual Android systrace and uploading to tool. But all instrumentation is with Gradle plugin.
It makes a lot of sense to have a trace related to like a page loading because that's what you care about. So that's pretty cool. So there's an iOS equivalent of this that basically does similar things, kind of, or is it pretty different?
Yeah, actually, we are doing exactly the same for iOS. I just don't have exact example here, but for iOS, from which information can provide, it's exactly the same. So we can make same instrumentation, and we are building same execution path for it. Just yeah, so we can do the same for iOS. But in general case of iOS, it's slightly more complicated because Android has this quite well-defined platform for making tracing. So it has system tracing, it has some events around choreographers and all that. In iOS, for sure, Xcode has some profiler, has some tracer, but it's really poor in comparing to Android developer tools.
How do you determine what you want to profile? Because like the engineer's not writing any code, right? So like it seems like it's fragment focused and maybe UI event focused. How do you guys like let's say this translate does this I imagine you have to do maybe there's a different grade of dependency if you're using compose maybe the new way to build UIs because compose doesn't necessarily use fragments. Some people might use compose with fragments, but some people might not. Like how do you guys kind of build this in a way that this kind of works for maybe multiple use cases?
Yeah, it's really cool question. It's what we started from, that such tools should cover any cases. It's just useless to make it only for one cases and one case. And we make it with our iterative procedure. We first time we are instrumenting all, and we have instrumented compose, we have instrumented every used framework, and then we already optimizing some metric to not lose some execution methods. For example, if something is executed in another thread, we have to see that something was executed, and what and to allow to build execution path for this method. I can not say exact approach how we are doing that, but logic around optimizing this is to, if something is executed, we have to show something here. So we cannot fully ignore some stake trace in any threads. We will have it anyway.
So what you're saying is this tool works with Compose and with the XML layout view system. It works with both right now. Nice.
Yeah.
So basically, if I use this tool, I could like see how efficient the compose is being, right? I could put it inside like a view class and then check the stack.
Yeah, actually, if you will use it with app which is Compose, you can see all logic which Compose is really executing in your app, all which is really executed, and you can check with that if Compose causes any performance degradation of your application. I would say in that way.
Okay, gotcha. Thanks.
Anybody else have any questions?
I guess mine are more around the iOS portion, so I don't know too much about that. But I think I saw or heard or this is a web view, like you can or is this all local? I guess is more my question now.
What we are showing here is all local, and yeah.
Okay, okay, that makes sense. No.
I guess I'm curious, are you all doing profiling and performance testing on your own apps? And are you familiar with on the Android side with these Android profiling tool, or what's the culture around performance within your teams, and what level are you doing some of this performance optimization?
I work at like a startup, so it's not as prevalent. I've heard of a lot of these tools like tracing and profiling and Perfetto, but um, I guess at a smaller company, unless you see a visual problem that users are complaining about, you're not, for the most part, gonna fix anything. For the most part, what I would say maybe a normal Android dev that doesn't work at a big company might do is I think it's pretty standard to run like Leak Canary, which is a tool that detects memory leaks, which is generally related to um, holding reference to something, and that basically causes your app to crash eventually or it gets slow. That's generally, but this I think, yeah, like maybe I've dealt with mostly business apps, so I have dug into this and I have had engineers dig into this, but generally the first pass after trying to fix memory leaks, which is I would say what most people are trying to focus on, is use Leak Canary to solve that. But yeah, like getting into this, I would say the reason why people don't use these tools is because they're so complicated, right? So I guess you're solving a problem there. So it's really hard to understand it and read it. I don't know about anybody else.
I mean, my company was driven by hey, the size of the app and resources and like that. What's like useless code that isn't there? How can we reduce the size and stuff? Normally for like a bug and that stuff, we'd look at like the memory graph and then go from there to see if there's any retain cycles. And like the last thing I would do would pull out instruments. Like I don't like Xcode instruments, so I definitely use some other tool, but it's just not something at hand, at least for me. I haven't gotten that far where I'm optimizing that much. I'm more the guy that'll put in like a print statement like, oh, let's start time and then minus the start time, and okay, it took that long, so that's kind of where I come from. I would see a huge benefit if like it could be aggregated with all the developers running in a development environment, like kind of seeing different numbers, because like on one machine is unique. Maybe on multiple machines, you could see something different. Maybe it'd just be a better kind of dev ecosystem. That's kind of my thoughts on it. It looks really useful, but I'm not always looking at performance. I'm hopefully writing performant code, but yeah, I'm not always like observing that, I guess.
I think what would be interesting of this is like one thing that I've gotten asked, like as like an engineer from like upper management, is I want you to improve the load time from login to seeing the first screen. So I think this would be a really good tool for something like that. Like, because right now, like it's almost like if you can make that like continuous integration, or maybe this works with continuous integration somehow, but like if you can make this like, hey, the login to home screen, that's kind of hard to test as well in Android in general. But like login to home screen takes 5 seconds to load because of some problem. So are we like what can we do to make that if we can't solve the backend problem, how can we make that appear to be quicker by preloading APIs or multi-threading or anything like that? Like what can you do from a front end engineer to make the problem kind of hide the problem, I guess. It's something that I've been asked. So like that would be an interesting use of the tool. That like I like there's no, as far as I'm aware, no easy way to kind of measure that and measure improvements over time.
I can share a little bit of my experience on this as well, because like you guys have probably heard of Sentry if you're in this market as well. So we've been using Sentry pretty heavily. And we do a lot of those like performance tracking with the, what's taking, like you were just saying, like how much time does it take to go from like the launch screen to the first screen they see, or if they launch any part of the app, how long does that take? And then we've had it hooked up with our backend as well, so we can see if they're like API calls that are taking longer and not just the app. So yeah, we do a lot of those things. I think kind of like Zach, you were saying, like if something just slows down, then like the last thing is kind of like, okay, let's run it manually and then see what the tracing says. But once we have like tracking going on the network, or like in our case, we're using Sentry, then we can kind of see already like here's an aggregate or anything going on. If there's like a new release that's slowing down things, then let's try to like dig into a little further using the Sentry stuff and then kind of go from there and see where things go.
Yeah, in that pipeline, I think tools like Sentry is still really important because it makes the signal when we need to optimize really something inside mobile application. Yeah.
Does Sentry work by like manual traces, or
Similar,
or is it like a Gradle task?
You can put, I think you can put a Gradle task. We put manual because we're very specific for what we're doing.
Well, I think one thing that I saw that was interesting on like the Twitter on Twitter was it's hard to know on Android when a page is actually loaded. So like that's kind of interesting if this tool like there's no active use of a thread, so it's probably loaded or something like that.
Good point.
But I saw some people complaining that they're like people assume that just because you do this X thing that the page is loaded, but there's actually some background things that might happen that actually is when the page is loaded, and you're not measuring the full length of when the page is loaded. I just saw that on Twitter.
And stuff?
Like I don't remember what it was, but like essentially, I think
Makes sense, I guess.
Whoever, I don't remember the guy who's always talking about leak canary and that kind of stuff. Yeah, he basically like saw him post that basically a certain event that a lot of people assume is when the UI is rendered is not correct.
It's true. I think that's true because like we also put like we emphasize loading states as well, because there's like one part can load but the others are asynchronous still. So if we just did the first load, it would technically still be like the raw loaded state. Yeah. even if we got the data, there's that time between the data that is actually different. So yeah, makes a lot of sense. Well, that's kind of where we put that's also why we put manual tracing, I guess. We put ours in like certain places where we know that the data is there. But yeah, I wonder if there's like an actual API or something.
Figure out when the page is loaded. I don't think there is. I think that's what he was complaining about.
Fair. Yeah, that makes sense.
Yeah, so essentially you manually put those loading states and say, you know, here's first load and here's guessing when the end of it is.
I mean, you'd know when the end of it is, I guess, but yeah, like something like that, I guess, loading states and, you know, tracking when the loading states are finished.
Yeah. Yeah, I mean, that's definitely, you know, to go back to the point about app start, that's one of the biggest things that we see with clients is like they want to, you know, optimize that. And one of the first things that they ask us is like, can we do a trial and test app start? Just to, because there's so much happening at that point. And I know, what's it called? There's like on iOS, there's you could basically set like a page order or something, and I think there's something similar with Android where you can actually tell it to load certain libraries in order. So I know there's a lot of different tools around that as well.
Baseline profiles.
Yeah, baseline profiles for Android and then order files, I think, for iOS.
Anybody else? Anything else they want to talk about? Otherwise, we can just hang out. Cool. Well, thanks for the talk.
Thank you all.
Thank
Here.
you.
It was great. It's very interesting.
Yeah, that was good. Nice to meet you all.
Yeah, nice to meet you.
Well,
Nice to meet you.
Nice to meet you. See you.
It'll be posted to the YouTube. I can't see the full post, but it'll be eventually posted to the YouTube as long as product science is good with it.
Yeah, I think we are good with it. Sure.
Oh, actually, I need to hit stop recording.